So far we learned how to do addition, subtraction, multiplication, division, the modulus operator. So we learned how to do the simple arithmetic operations. We learned about parentheses and order of operations. We learned about combined arithmetic operations. Now, what if I want to do like kind of scientific calculator things, you know, square root and power and sine and cosine? How can I do that? So the nice thing in Java is that there's a class called the math class. So it's a class that someone wrote, and it's provided part of the Java API. So Java provides some functionality that we can just use. So this is called the Java API. And it's going to provide us with the functionality of a scientific calculator. So for example, if I want to find the absolute value of a number, or I want to raise something to a power, or I want to do the square root, I can use some of those, the functionality in the math library. So how do I know about all these? Well, Google. Google is our friend. So if I come here and I open up a new tab and I want to search the math class, I can just say Java math class. And you're going to find a lot of references once this comes up. There are wiki pages and pages that people wrote and Stack Overflow. But the one that I want you to look at is the Java documentation provided by Oracle. So Java is provided by Oracle. They provide documentation for all the API that they provide. And so this is the best documentation that you can look at. And it's a little slow, so let's bear with me. And instead of searching, you can just go and click on the link in the slides, but I want to show you that from Google you can do it. And so here, this is version 8 from Java, so I'm just going to click on it. And at first, when we look at this, it looks a little scary, but I want to show you how to read this. So the first part at the top, there's a lot of writing, just skip over it. And then it starts talking about methods. So when it talks about methods, it's talking about the functionality that's provided, kind of like a graphing calculator or a scientific calculator, and it tells you all the options that are available. So here we're going to look at this. It's a static double. We're just going to ignore that. And here's the method name and a description. So ABS, it tells me in parentheses what it takes as input. So what is it that you need to give to this method for it to do its job? So if I want the absolute value of a number, I can give it a double. I can give it a float, I can give it an int, a long, and here when we say int, it's going to include also the byte and short. So basically any number that you give it, it's going to tell you the absolute value. And it tells us here a short description, returns the absolute value of an int value. So remember, absolute value means that it's going to tell you the positive version of it. Okay. So here, let's look at the math class. So if I have, let's say, I want system, I want to print dot, and in NetBeans, if you wait a little, NetBeans will actually start populating those methods for you. And so if I just come and I click on one of them, for example, actually what I just showed you in the Java documentation is going to be here. So here it tells me that it returns the absolute value of a double value. If the argument is not negative, the argument is returned. So if you give it a positive number like 7, it's going to give you the 7 back. If the argument is negative, the negation of the argument is returned. So I'm just going to double click on it. And here I just picked some random variable. I'm just going to put 7. So if I try printing the absolute value of 7, well, 7 is already positive. So I'm just going to get the 7 back. So I get 7 back. Well, what if I want to print the absolute value of negative 7? So if I put a negative 7 here, well, the absolute value of negative 7 is just 7. Okay, so I'm going to get a 7. And so the absolute value is nice when you're determining distances, like, you know, what's the difference between 10 and 5 as a distance? You don't want to say, oh, it's 5 or negative 5. You just want to say kind of like the absolute value, the absolute difference between two numbers. You know, what's the difference between what Mary has and Adam have? You know, if he has $100 and she has $30, what's the difference between them? You don't want to say negative 70 or 70. You just want a positive number. So that's the absolute value. Another method that we're going to use is the POW. And you can see that there's sine and cosine. You can look at this on your at your free time. But I just want to show you the POW. So let me just search for it. POW. Okay. And here we see that POW takes two numbers as input. And if I want more details than just this line that's down here, I can click on this method. And what it's going to do, it's going to give me like a whole bunch of information. I'm not going to read all this, but I just want here to see what it's doing. So it says returns the value of the first argument raised to the power of the second argument. So if you give it two numbers, it's going to take the first number, raise it to the second number. And when you take a double, raise it to a double, or any number, raise it to a number, you're going to get a number back. And so this variable, this data type that comes before the method name, this tells you what it's going to return. So if you give it a double, raised to a double, you're going to get a double back. Now, we don't see any version here for int or float or byte. Remember that double is the biggest type of data type for numbers. So a double has enough space to store a float, a byte, a short, an int, a long. So as long as you write a method that accepts a double, it will accept all different numeric data types. So you only really need one version of this method. Let's give it a try. So let's come here and let's do this. Let's say I want to raise math dot power 2. Well, 10 squared is 100. Let's verify that. We got 100. Okay. Now, if I try doing math dot pow 2 comma 10. Now remember, 2 comma 10 means 2 to the power 10. It's not the same. So here order is going to matter. If I take 2 to the power 10, I get 1024. Okay, so here 2 to the power 10 is 1024. So order matters. It's going to take the first argument, raise it to the second argument. The third method that I want you to memorize, so these three methods I want you to memorize out of the math class for now, the ABS, absolute value, the power, and the last one I want you to memorize right now is the square root, SQRT. Notice here, square root just takes one number. So if I say, what's the square root of 49? I'm going to get that the square root of 49 is a 7. So the square root of 49 is 7. I get a 7 back. So those are three methods that I want you to memorize out of the math class. We are going to be using them quite frequently in this course, and you'll memorize them on your own anyways. The last thing I want to share before we stop for the classwork is creating some constant variables. So remember, a variable is a space in RAM that we store information in. When we create a variable, we can change its value. So here, let's say I have, a student count like we did before, and I said we have 10 students, and then I was able to go and say, well, I want to change my student count and add 1 to it, and maybe I just want to all of a sudden say my student count is 20. Variables can change. Okay, so variables can vary. That's why they're called variables. They vary in what they store. Sometimes you might want to create a variable that you don't want to change. For example, I want to say class capacity. What's the class capacity? Well, I only have 24 computers. I don't want someone to come by mistake and say, oh, well, I'm going to make the class capacity 100. That's bad. I don't want them to change it. I want it to be constant. If you want a variable to be constant, what you do is you use a word called final. And what final does, it variable and makes it unchangeable. So no one can change it. So notice here, this line that was okay a little bit ago now has a red wiggly line. If I come over, it says cannot assign a value to final variable class capacity. Class capacity has been created with a final keyword. It's final. You cannot change it. So this is really nice to do when you are creating variables that you want to make sure they don't change. Final variables should They don't have to, but it's good programming practice to make them all uppercase letters so that anyone who looks at the code down, below, where you're doing a print of this variable or doing anything, they know that this is a final variable. So final variables out of, naming convention should be used, should be all in should be in all caps, capital letters. I want us to look at the classwork that you will need to do. So here you will create a new project in NetBeans, and the purpose of this project is to calculate the volume of a sphere. So the volume of a sphere, the formula for it is 4/3 pi r cubed. So what I want you to do is I want you to create some variables. So here I ask you to create a constant float. So remember, a constant means you're going to use the word final. Float called pi and set the value to 3.14. So I'm just going to do this line with you. So we said it's final, we said it's a float, we said it's pi, and we said it has the value 3.14. And because it's a float, remember to put the F. So this is the first line of code that you would need to do. And then you'll create a variable, a constant byte 4, a byte 3, a byte radius. This one, notice this one is not constant, it's not final. And then you'll create a volume double and set it equal to 4 divided by 3 times pi times math.pow radius 3. So this is going to be the radius cubed times pi, which is the 3.14, times the 4/3. Now, I want you to remember that if you do 4 divided by 3, 4 is a byte, 3 is a byte. Byte divided by byte is whole number divided by whole number. You're going to get a whole number back. So if you just type in this expression like I have typed here in the slide, 4/3 is going to give you 1. It's not going to give you 1.333. So I want you to think how to fix it. I don't want you to change the type to be a decimal number. You can't change it because I told you I want it to be a byte. So you can't change it to float or double. You can't use the numbers 4 and 3 here because I told you you have to use the variable. So your only option is to use casting. So make sure you do the casting on this line. So this line needs to be fixed to do casting. And then finally, you're going to print the volume of the sphere to the screen, test it on NetBeans, test it on HackerRank, and then submit your code on Blackboard.